All right, so let's talk about hardware terminology. So a computer system is made up of all of the different components that we're going to take a look at here. Okay, there's the processing unit, which contains the central processing unit and main memory. We have input devices like mices and keyboards and cameras and, if you're working on an aircraft, laser targeting pods or whatever. Anything that takes some information from the real world and digitizes it and brings it into the computer. And we have output devices. Could be monitors, could be printers, could be speakers. There's all kinds of different output devices as well. Teletype machines, you name it, there's some way for the computer to get information to a human user, right? Then we also have different types of storage devices. Okay, we've got hard drives, and whether it's platters or the new SSDs, DVDs or Blu-rays or USB drives. There's any number of ways to store information. Even tape drives. In some server operations, they still use tape drives because of the amount of data that they can store on them. So we have all of these different types of components, and no matter whether you're working with an embedded system, which is something at the hardware engineering stage, you're building a microcontroller or something like that, or you're building a desktop computer application. Software is used to run computers and to make the computers do useful things. So this is what's made up when we talk about hardware terminology. We're mainly concerned with input and output devices, storage, and processing units. Now, as far as how it's all organized, within the central processing unit, we have the control unit and the arithmetic logic unit. And we're not going to get too deep into it here because you're going to take a whole course on this called computer architecture. And it's going to get into the nitty-gritty of how a CPU actually does what it does. But the control unit is responsible for controlling the paths called buses in the computer. And the buses carry these digital signals that represents data from memory and to the ALU and to various other places, right? So the CPU stores the instructions that the computer actually uses to do its thing, right? And it stores the results of that in memory. And there's different types of memory. There's, your registers, which are the lowest form of memory, or the highest form, depending on how you look at it, that are used to very quickly perform operations. So if a CPU is adding two numbers together, it actually has to have those separate numbers residing in its registers before it can perform an operation on them. So it's going to pull the data out of the main memory and put it into the registers. There's also level 1 cache, level 2 cache. I'm not really concerned about you guys knowing those things. Just understand that memory is where temporary information is stored as the CPU and the control unit are doing its thing, right? And then if we have some kind of useful information that results from this program, then we might put it into external storage, right? So say you generate a Word document, right? Well, you're going to put that in external storage because if you put it into main memory, what's going to happen to it? Well, it's going to get deleted because main memory is volatile, meaning it doesn't save its state after it loses power. So we have things like hard drives and thumb drives to actually store our files once we're done with them. And then, of course, as we've already talked about, there's input and output devices. And they're often overlooked, but they play a huge part in any computer architecture, right? Keyboards and mice are the most common, as we've already discussed, as are monitors and printers for the output. But we also have internet or network connections. Those are input and output devices as well. Okay, so something to think about. Anything that takes information from the computer outside of it. All right, so let's talk a little bit about main memory. When a computer performs its calculation, it often needs to save intermediate results, right? So basically what it's going to do is it's going to pull information out of the memory, right? It pulls it out on the bus and it says, hey, ALU, do some stuff to it, right? And then it's going to say, once you're done, we're going to put it back in memory, right? Or maybe it goes from the ALU to the memory. But the point is that it's there for temporary use. and it's not the registers, because the registers are actually on board the CPU, and they're what's going to store, because the registers are like another set of memory, and it's going to pull the whatever operation it needs to. It's going to pull it from memory and stick it in the register, right? Register, right? And then the arithmetic unit's going to do some operations on it and then put it back in a register. And then the control unit's going to pull it out of the register and put it back in main memory. So we need to be clear when we're talking about memory. There's all types of memories, like I said, level 1, level 2 caches, but the registers are the onboard memory. When we're talking about memory, though, we're not talking about registers. We're talking about RAM, right? We're talking about, whoops, there we go, RAM. We're talking about read-only memory, okay? Okay, and like I said, RAM, which stands for random access memory. So when we say memory, that's what we're talking about. We're not talking about auxiliary memory, which you would also think of as, you know, your long-term storage or your external storage. Okay, that's completely different. So if you have any questions on this, let me know. It should be clear. It's the 21st century. I think most of us are familiar with the concepts of memory and storage, but if you're not and you're still unclear, talk to the internet, you know, ask your Alexa, hey, what's CPU memory? Or talk to me and say, hey, I'm not quite getting this thing yet. But for now, just know that its main memory is also called random access memory, or RAM. So how does main memory work? Well, you can think of each memory kind of like a mailbox, right? And the size or the capacity of the memory is described in terms of the number of bytes. So each of these 6 storage boxes that were listed on the screen here is used to store the word emu, and each of these locations is a byte. So if we take a look at this, we are storing the 3 letters E, M, and U. And don't ask me why we're using emu, because I don't know. Just ask the author of the book. Okay. Computers don't understand the alphabet, right? It only understands ones and zeros. The alphabet is a connotation that humans put on these values. So to the computer, it's just numbers, right? So the letter E in binary is represented by this code right here, okay? And if you break it down, it's basically a binary value that corresponds to a number. And that number is going to correspond to an ASCII value. And so it takes 2 bytes to store each letter in memory. So E is stored between here and here, right? So as we can see, we've got the zeros, boop, and we've got the non-zeros going in there, right? So those 2 bytes is what makes up the letter E. So, and if you want to learn more about ASCII, you can go to the ASCII code website, and you can look at this YouTube video here. I'm not going to make you watch it right now, but it's kind of important concept to understand that letters and symbols are represented by a number. Now, ASCII is kind of like the original, it's the grandfather coding scheme, and now we're into Unicode, and there's different versions of Unicode, and yada yada yada. I'm not going to bore you with it. But it's important that you understand that letters are represented by numbers, and those numbers are represented by binary values. And it takes 2 bytes to store each value in memory. So when we're talking about computer science and introduction to programming and so on and so forth, it's important to understand the terms that we're going to use. And we're going to be talking about binary things quite a bit. So it's important to understand the different terminologies that's used around that. So there's a bit, which is a single value, which is a 1 or a 0, because a binary state only has 2 positions, on or off, 0 or 1, low voltage or high voltage. And you'll get into all that in computer architecture. But there is also a nibble. Honest to God's truth, nibble is 4 bits. Okay. Now it's not used very frequently, but it does exist. Okay. Now, one that you should be familiar with by now is a byte. But what is a byte? Well, a byte is 8 bits, or 2 nibbles, right? A word is typically is 16 bits or 2 bytes. Okay, and we often break it down into, nibbles like this. So you're going to see this often where we have it represented in these sections, right? And that's just convention. But we also have a double word, which is a 32-bit binary number, right? Or it's 2 words, right? So here's a word, word 1, word 2, right? Or we could break that down into 2 bytes for each word, right? So there's byte 1, byte 2, byte 3, byte 4, right? Or we could break it down into nibbles, right? Nibble 1, nibble 2, nibble 3, nibble 4, so on and so forth. You get it, right? So when we're talking about numbering conventions, these are the terms that you're going to use. We also have significant bits, which is, in this situation, we have the left side is the most significant bit and the right side is the least significant bit. But this is not the only way to represent data. There's also a thing called, there's a big endian and a little endian, right? And depending on the type of computer architecture that you're working on, these things might actually be swapped. And that can completely change how your data is interpreted and represented. So just be aware of that. We'll get to talk about that again in computer architecture, but understand the concept of a most significant bit and a least significant bit. So just like numbers, if we have 1,000, right, this is our most significant bit, right, because it's the biggest number. So what about auxiliary memory? I know we kind of went off topic with a discussion of binary terms, but when we were talking about memory and all that, it was important to clear that up. So let's get back on the topic of a different type of memory, and that's auxiliary memory, right? So when we're looking at our computer architecture here, we're talking about external storage, okay? And these are things like hard disks, solid state drives, compact disks, and all that other stuff. And the key difference between regular storage or auxiliary memory and main memory is that it's non-volatile, right? So after you pull the plug and remove power, the memory stays consistent. And there's a lot of different forms, as we talked about, SSDs and hard disks and flash drives and all that. And really the only differences between them is just their performance, right? Obviously there's different physical characteristics. Some are on spinning platters, some are on solid state devices. It depends, but basically they all do the same thing, and that is just to store information once the power has been removed, or for long-term storage. So when we're looking at the difference between the different types of storage, you got to look at whether they're online or offline. So like compact discs and USBs are referred to as offline storage because you can actually remove them from the system. There's different, price points with them all, like compact discs. Like, does anybody even use compact discs anymore? I don't know. I don't. Like, I don't even have a CD-ROM on my computers anymore. So I guess maybe those are even getting dated to be discussing, but it's in the text. But then you also have like your hard drives, right, which have like, huge amounts of storage spaces, into the terabytes. And then you've got SSDs now, and this is even getting old. This is, I think you can get computers that easily have, 1 terabyte SSDs on them now. And, compact disc, Blu-ray disc, whatever. The point is that auxiliary memory is for bulk storage. They're going to store a lot more than what your main memory is going to store. Okay, with the exception of some of these flash drives right here, right? They can be pretty big, but they can also be pretty small depending on the age of the flash drive. So speaking of drives, a drive is a mechanism that enables the computer system to access data on a storage device. Okay, a disk drive is a drive that's like a hard disk or a CD or a DVD, right? So, and there's some conventions that are involved in this when we're talking about the different disk drives. Like by convention, and we're talking Windows. Okay, we're not, for the sake of clarity, we're not going to have a discussion of Linux or any other operating systems out there. But for just on a typical Windows PC, by convention, C drive is going to be your main hard disk drive, right? and then anything else that you might have plugged in after that is going to be followed up with subsequent drive letters. Typically speaking, your first CD drive is going to be D. Of course, if you know what you're doing, you can go into the Windows operating system and you can change that and reassign it. But this is by convention, right? In the old days, the A drive was, used for the 3.5-inch floppy, and the B drive was actually used for the, was it 5.25 inch? I remember having those. So, not really hugely critical that you know this nowadays, because most of the stuff is, cloud storage this and, SSD that and whatever. But it's important to know your roots and where you came from, right? So by convention, this is typically what it is.